All right, in this video, we're going to look at some of the long questions in exercise 12. So on page 332, exercise 12, we're going to concentrate on questions 7, 9, and 10 because a few people have been having trouble with those. So first of all, question 7a, it says to find where the circle S cuts each axis and find the length of the chords of the circle it cuts off on each axis. So we are given the equation of the circle here. We have x squared plus y squared minus 6x minus 4y minus 12 is equal to 0. So if we wanted to draw a quick sketch to figure out what we're actually looking for, we get the center of the circle. So we have 2g is minus 6, so therefore g is minus 3. 2f is minus 4, therefore f is minus 2, meaning the center of the circle is the point 32, and the radius of the circle is the square root of g squared plus f squared, so that's minus 3 squared plus minus 2 squared minus minus 12, which gives us a radius of 5. So as a quick sketch, if we were looking at the center of our circle, which is C at the point 32, we're looking at quick sketch of our circle. It looks something like that, and we are looking for the coordinates of these points here where it cuts the x-axis, and we're looking for the length of this chord here, the length of the line. We are also looking for these two coordinates here where the circle cuts the y-axis, and we are looking for the length of this line. So these are the two chords that we're looking for. So let's concentrate on the x-axis first of all. We know that any coordinate on the x-axis has a y-coordinate of 0. So if we let y equal to 0 and substitute into our circle equation, we are left with, so x squared plus y squared, 0 squared is 0, minus 6x, minus 4y, so minus 4 by 0 is 0, and then minus 12 is equal to 0. You can either solve using, now in this case factors are not possible, so we use the minus b formula to solve, and we get x is equal to 3 plus or minus the square root of 21. You can change those into decimals if you wish, but third form is the most accurate. So now that we have this, we know that the coordinates of our 2 points here, a and b, let's call them, a is the coordinates 3 minus root 21 comma 0, and b is the coordinates 3 plus root 21 comma 0. So to get the distance between them, we simply subtract a from b. So we have 3 plus root 21 minus 3 minus root 21, which gives us a length of 2 root 21 units. So the coordinates of where it cuts the x-axis, we let y equal to 0, and then to find the length of the chord, we simply subtract the x coordinates. We do the same then with y, so at this time we know that any coordinate on the y-axis will have an x coordinate of 0, so therefore we are left with y squared minus 4y minus 12 is equal to 0. Now we can actually solve this using factors, so we have y, sorry, not x, y minus 6 and y plus 2, which means that we have y is equal to 6, y is equal to minus 2. So the two y coordinates are, let's call them D and E. We are looking at 0, 6 for D and 0, minus 2 for E. And again, length, we subtract E from D, so we're looking at 6 minus minus 2, which gives us a length of 8 units on the y-axis. So that's how we go about finding the chord. Now I want you to try question 7 part B yourselves, very similar, and use the same method. The next question I'm going to look at is question number 9. So in question number 9, we have a ring slides down a chute made of 2 parallel metal bars, L1 and L2, where each bar makes equal intercepts on the axis. So if we look at a quick sketch of the diagram there, we have 2 parallel bars, we have our circle with center C, the connecting point to this line L2 is N, we have a connecting point here, we have intercepts on the y-axis, we have the point Q, point P, and line 1. So what we're being asked to do here, at one instant, the center of the ring is at the point C, which is the point minus 3, comma 8. The radius of the ring is 3 root 2 over 2. So the first thing we are being asked to find is the equations of L1 and L2. All right. Now, equations of L1 and L2. Because we know that they are parallel lines, we can say that the equation of the line is y is equal to mx plus c. All right, we don't know what the y-intercept is, but because if they tell us here, sorry, it does tell us the bar makes equal intercepts on the axis. So because it tells us that the line L1 and L2 makes equal intercepts on the x-axis, that means that the slope of the line has to be plus or minus 1. Now looking at the diagram here, the slope of these lines is minus 1, so therefore we're looking at y is equal to minus x plus c. Bringing the x across, we have x plus y minus c is equal to 0 is the equation, the general equation of any line that is parallel to L1 and L2. So we're looking for specific values now. So given the information that we have here, we know the center of the circle is minus 3, 8, and the radius is 3 root 2 over 2. Here's where our lines and our circles intersect. So we know that the perpendicular distance, so if we look at our diagram here, the perpendicular distance from the center point to the line is 3 root 2 over 2, and we can use that formula to find out what our missing variable is here. So if we use the formula, so the formula is the absolute value of a times by x1, where a is the coordinate, the x coefficient, so 1 times by minus 3, plus b times by y1, 1 times by 8, and then we have minus c over the square root of a squared plus b squared, and that is equal to the radius, which is 3 root 2 over 2. So this is where we are looking at perpendicular distance formula. So multiplying across then and tidying up here, we have minus 3 plus 8 is 5 minus c, and multiplying this by root 2 here, we get 3. Our absolute value means that we can either square both sides or let it equal to the positive and negative. In this case, it's probably easier to equal to a positive and negative. So 5 minus c is equal to plus 3, and 5 minus c is equal to minus 3. Solving for c then, we have a c value of 2 in this case, and a c value of 8 in this case. So going back to our equations of our lines, we can have the equation x plus y minus 2 is equal to 0, and x plus y minus 8 is equal to 0. In this case, this one is line 2. The reason I know it's line 2 is that the y-intercept, if we rearrange this into the format y equals mx plus c, we would get y is equal to minus x plus 2, which is this one here, as we're looking at a lower line, and this one we're looking at y is equal to minus x plus 8, which means that this has to be line 1. So that's the equations of line 1 and line 2. Now to find the points where line 1 and line 2 cross the x-axis, we simply let y is equal to 0. And to find the points P and Q here, if we're looking for point P, we let line 2 equal to, so y in line 2 equal to 0, which means we get minus x is equal to minus 2, and therefore, so for part 2 there, I'll just rub this out up here. For point P, y is equal to 0, therefore 0 is equal to minus x plus 2, meaning that x is equal to 2. And remember, it makes equal intercepts, so if the y-intercept is 2, the x-intercept also has to be 2. So P is the point 2, 0, and similarly, if we let, for line 1, if we let y is equal to 0 to find the x-intercept here, we would get x is equal to 8, and therefore Q is the point 8, 0. So that's part 2 of the question 9. Then, next thing we need to do is find the equation of the ring at the instant shown. So to find the equation of the circle, given that we have the center point, which is the point minus 3, 8, and we have the radius 3 root 2 over 2, we simply input it into the equation of a circle. So we have x minus h to be squared plus y minus k to be squared equals r squared. We don't use the general equation of the circle in this case because it's easier to use this format. So putting in our information, we have x plus 3 to be squared plus y minus 8 to be squared is equal to 3 root 2 over 2 to be squared. We now have to multiply it out. So when we multiply this out, we get x squared plus y squared plus 6x minus 16y plus 137 over 2 is equal to 0. Now you can leave it in fraction form here, or else you can multiply across by 2 to eliminate the fractions. 2x squared plus 2y squared plus 12x minus 32y plus 137 is equal to 0. Either or. This is perfectly acceptable for full marks. Next, we need to find the point N where the ring touches L2 when the center is at C. And for that, we're looking for the point of intersection of a circle and a line. So we now have the equation of our circle. We have the equation of our line, which is x plus y minus 2 is equal to 0. And where we are trying to solve a linear and quadratic equation, or linear and circle equation, we rearrange the linear equation and then input that value into the quadratic. So if we're looking at rearranging this here, we can rearrange it to say that x is equal to 2 minus y. So we're bringing the y and the 2 across the other side, or you can leave it as minus y plus 2, it doesn't matter. And then we're going to input into the circle equation. So we have minus y plus 2, or 2 minus y, either or. Plus y squared plus 6 times by minus y plus 2 minus 16y plus 137 over 2 is equal to 0. Multiplying out, we have y squared minus 4y plus 4 plus y squared minus 6y plus 12 minus 16y plus 137 over 2 is equal to 0. And then tidying up, we have 2y squared minus 26y plus 169 over 2 is equal to 0. From here, you can either use the minus b formula or factors, but using the minus b formula, we get y is equal to 13 over 2. There's only one root to this equation here, and therefore x is equal to minus 13 over 2 plus 2, which is minus 9 over 2, meaning that our coordinates of the point N are minus 9 over 2, comma 13 over 2, and that's the intersection point. So that's question 9. Now in